welcome back to another M&S tutoring video. And in this video we're going to be learning about the area and the perimeter relation of two similar triangles. So if two similar triangles are similar in the area, both triangles are proportional to the scale factor. Well, what does this really mean? Well, this means that, let's say for example, you have triangle A, B, and C. Right? You have this triangle over here. Let's call this triangle A, B, and C. Say you knew all sides of triangle A, B, and C. You knew that side AB was 5 centimeters, side BC was 4 centimeters, and side AC was 3 centimeters. You knew that triangle ABC was similar to triangle DE and F, right? So let's make triangle DE and F over here. Triangle D, E, and F. To know why both of these triangles are similar, please go back and watch my other video on identifying and solving similar triangles. It'll help you get a better insight as to how you know whether or not if two triangles are similar or not. So let's continue with this. You knew that side DE was 10 centimeters, side EF was 8 centimeters, and side DF was 6 centimeters. Now, what is the relationship between the area of both of these triangles? Well, first of all, let's look at the area of ABC. So the area of triangle A, B, and C right now is simply just 3 times 4, which is 12, divided by 2, which is 6 centimeters squared, right? Base times height divided by 2, simple math. So now the area of triangle DEF is quite simply the same thing. It's basically just 8 times 6 divided by 2, which is 24 centimeters squared. So I'm going to write that here, 24 centimeters squared, right? So what is the relationship between both of these areas? Well, right now you could say that 24 is 6 times 4, right? 24 is 6 times 4. Or you could say that in this case 6 is 1/4 times 24. You could also say that. Well, how can you relate both of these without having to multipliers or divide one by the other to find the relationship? Well, the relationship itself is in the scale factor. So the scale factor is basically the relationship between two sides of similar triangles. So between side AC and side DF, we know that the scale factor is times 2 because you have to multiply side AC by 2 to get side DF. Apart from that, you could also multiply side DF by 1/2, right? Sorry, 1/2 to get side AC, right? So the scale factor in this case is either 2 or 1/2. Now, what's the relationship between 2 and 1/2? And in this case, it's 4 and 1/4. While the relationship is basically the scale factor, right? If you square it, right? So let's say SF is the scale factor. If you square it, whether it's 2 or 1/2, you get the area relation, right? So that's the relationship. Now, say for example, you only knew the area of A, B, and C, and you didn't know the area of D, E, and F, but you knew both of them were similar, and you knew the scale factor. All you had to do was square the scale factor between triangle A, B, and C to triangle D, E, and F, which was 2, and you had to square it, and you had to multiply that, which in this case was 4, by the in this case it's the area, right? So you have to multiply 4 by the area to get the area of triangle DE and F. So I hope that's a bit more clear to you guys now on what the relationship is between two similar triangles. All it is basically the scale factor squared, and you multiply it by basically the area of the previous triangle that you're trying to get. So now let's move on to the perimeter relationship of two similar triangles. The perimeter relation is very simple. It's a lot more simpler than the relationship between the area. All you have to do is you have to look at the side length ratio and you have to multiply it by the perimeter. So say for example you had the same two triangles. You had triangle A, B, and C, with with side AB being 6, side BC being 5, and side AC being 4. And you knew that it was similar to triangle DE and F, right? So I'm going to make triangle DE and F over here. So D, E, and F, right? You knew both of these triangles are similar. And you knew that side DE was 12, side EF was 10, and side AC was 8, right? So let's look at both the perimeters of both of these triangles, and maybe we'll think of some of a relationship pattern between the side length ratio and the actual perimeter itself. So first of all, before actually finding the perimeter, let's look at the side length ratio. The side length ratio is the same side length ratio as above, and it's from triangle ABC to triangle DEF. It's times 2, the side length ratio. And from triangle DEF to triangle ABC is actually times 1/2, right? So now let's look at the perimeter. So the perimeter of triangle A, B, and C is actually, I'm just going to punch into my calculator, 5 plus 6 plus 4, which is 15 centimeters, and the perimeter of triangle D, E, and F is that's 30 centimeters, right? So now that we know the relationship between both the perimeters, we know that the perimeter is also equal to the scale ratio. So the difference between the perimeter of triangle A, B, and C is times 2, and the same thing backwards is times 1/2. So the perimeter ratio is basically it's basically you have to multiply it by the scale factor itself to find the perimeter of the other triangle. So the two main things to remember in this case is the perimeter ratio from triangle number 1 is A plus B plus C is equal to the perimeter, and for triangle number 2 it's the scale factor times A plus B plus C is equal to the perimeter. So that's the end of the video, guys. I hope you learned something new as to how the area relationship of two triangles can be found using both the area and the scale factor, as well as how you can find the perimeter doing the same thing. If you have any comments or concerns, please feel free to leave it down in the comment section below, and I'll get back to you as soon as possible. Other than that, thanks for watching, guys.